In the final two lessons of Mod 7, we're going to take a look at how you can simplify complex fractions. Now, a complex fraction is a fraction, so it has a numerator and a denominator, but there will be a fraction in either the top or the bottom, or very often both. So it is a fraction that has a fraction in its numerator or its denominator, and it can have more than one. Now, you notice in the title here, I say complex fraction type 1. Now, type 1, and that's just my designation for it. You won't find that in a textbook. But complex fractions of type 1 have merely a single fraction on top and a single fraction on bottom. An example might be 1/2 over 2/5. That would be a complex fraction of type 1, a single fraction over a single fraction. Now, to simplify a complex fraction, we're going to do this using a method that you're really already very familiar with. You're going to remember that a fraction line means to divide. So this really means 1/2, the numerator, divided by 2/5, the denominator. And you know how to divide fractions or divide rational expressions. It is to keep the first fraction, change the operation of multiplication, and invert or flip the second fraction. Sometimes we nickname it keep, change, flip. If you can reduce on the diagonals or up and down, then do so. You can't in my example, so I will just multiply. 1 times 5 is 5, and 2 times 2 is 4. This complex fraction simplifies into 5/4. So that's what I'm going to do with my example problems. They won't all be just arithmetic fractions. They will include variables, but we're going to treat them all as division problems if they are single fraction over single fraction. Let's look at some. Number 1, you see that it is a single fraction, 18 over 7x, over a single fraction, 9 over 7x. So I wish that this were a little bolder to be the fraction line that separates the top from the bottom of the complex fraction. All right, we know that that means divide. So this changes to 18 over 7x divided by 9 over 7x. Division problems keep the first fraction, change the operation to multiplication, and invert or flip the second fraction. Now we look, and sometimes I nickname this bow tie. We look this direction, this direction, this direction, and this direction to see if there's any reducing that we can do. And sure enough, 7x goes into itself once, 7x goes into itself once, 9 goes into itself once, 9 goes into 18 2 times. Multiply the tops for 2, multiply the bottoms for 1. You've got an improper fraction that simplifies to 2. So this complex fraction simplified into the number 2. Let's look at another one. This is of type 1. Remember, that's just my designation because I have a single fraction over a single fraction. So I will write it as 2 over x minus 1 divided by x over x minus 1. Keep the first fraction, change to multiplication, invert the second fraction. If I needed to do any factoring of polynomial expressions, I would. But there's no factoring of x minus 1. It is a prime. So now I see if I can reduce. And sure enough, x minus 1 goes in there once. X minus 1 goes in there once. No other reducing. Multiply. 2 times 1 is 2. 1 times x is x. I'm done. That simplifies to 2 over x. Okay, let's go down to our last problem. A little far. There we go. It is type 1 because there's one fraction over one fraction. So I have x plus 3 over 3 divided by 2x minus 1 over 6. Keep x plus 3 over 3. Change to multiplication. Flip 6 over 2x minus 1. Check to see if any polynomial can be factored. X plus 3 cannot be factored. 2x minus 1 cannot be factored. So now I'm checking to see if there's any common factor, any greatest common factor that I can factor out. 3 goes into itself once. 3 goes into 6 2 times. There is no common factor. This is an x plus 3. This is a 2x minus 1. I'm sorry, I don't know where that went. I'm very sorry, it just changed screens on me for a second. So there are no more factors to divide out, and I am left with a 2 times an x plus 3 over 1, which I don't need to write, times 2x minus 1. You can leave the 2x minus 1 in parentheses, but you usually don't unless there is a factor on the outside. You don't need to distribute the 2. It's okay if you do, but you don't need to. Now, we're finished. Sometimes students are tempted to say, oh, but 2 can be divided out. No, 2 is a factor of the numerator. There's a 2 and there's an x plus 3. 2 is not a factor of the whole denominator because it doesn't say 2 times the other factor. It's 2 times x minus a 1. So 2 is not a factor down there. It cannot be factored out of that. We're done. That's in lowest terms or simplified. So that is type 1 of simplifying complex fractions.